All right, and then the fourth one, fourth intermolecular force we're going to take a look at is ion dipole forces. This one's a little bit different than the other ones. And the reason that it's different is between different types of molecules. So for example, when we took a look at London dispersion forces, dipole-dipole forces, and hydrogen bonding, we looked at the same molecule interacting with itself. So when we talked about water, we talked about how one water molecule interacts with another water molecule. Here, we're going to have different types of molecules interacting with each other. And so when you're thinking about a pure compound, its melting point and boiling point, we don't consider ion dipole forces. So we're mostly going to focus on the first three forces, but this one's important in solutions, which we'll learn about in the next section. As the name implies, ion dipoles, it's a force between an ion and dipoles. Kind of duh there. But it's something like sodium chloride in water, right? Why does sodium chloride dissolve in water? Well, remember that sodium chloride is an ionic compound, so it's made out of positively charged Na pluses and then negatively charged Cl minuses, and the chlorines are indeed bigger than the sodiums. And so there's our ions, and then what's our dipoles? Well, our dipoles are our water molecules. So there's a water molecule right there, and if we think about the dipole, it generally faces like this. And you can see I put the negative end of the arrow towards the positive ion, because remember, opposites attract. And so this is what happens when you dissolve salt in water. The ions of the salt get surrounded by the water molecules in order to maximize this positive and negative interaction. And then the same thing happens with the chlorine, but kind of the reverse. Instead of the negative part of water pointing towards it, it's the positive end of water that points towards it. Right, so remember, opposites attract. You can see that this force is different than the other one because, again, we're talking about two different compounds. So we're not going to talk about melting point or boiling point or anything like that. But this simply helps us explain why salt, NaCl, dissolves in water. Because water is a polar molecule. So we can have these ion dipole forces. But if you try to pour some salt in some oil, it's not going to dissolve, and not in oil. Oil is a nonpolar compound, and so you cannot have these ion dipole interactions, and so you don't separate the ions from one another, and thus it doesn't dissolve.